Alright, so this is going to be a review for our second geometry test. Again, this is just meant for my students, not really intended for anybody else. This is just prepping for our test 2 review. We covered a couple of topics to get ready for test 2. So let's go ahead and talk about them pretty briefly. Feel free to pause, rewind, slow down, whatever you need. We're going to start off with similarity and congruence. So remember, congruence is just when two shapes are essentially the same. They have the same dimensions and whatnot. They might just be set in different rotations. So let's talk about how to deal with similarity. Similarity is the one that you're definitely going to be tested on. You will be tested on both, but similarity is the one that actually requires some math work. So with similarity, just remember you're going to be given two shapes, and I'm going to tell you that they're similar. For example, two triangles, two rectangles, octagons, something like that. There we go. And let's say that these two triangles are similar. And on the test, I will tell you the following shapes are similar. You know, triangle ABC, DEF, whatever it is. They will be similar. Because I say they're similar on the test, because that is a qualification, we assume that they are, and we proceed with the math for it. Okay? So don't just look at two shapes and assume that they're similar. If it does not tell you that they are similar, then assume that they are not. So let's go ahead, and I'm going to give you that this value is, I don't know, 3. We can make this 5, and then I'll make this 30, and I will ask you what is the value of x here. What you'll know is that because these are similar triangles, they must have similar and proportional sides. So we'll set up our ratio or our proportion. Okay, and you'll set it up like this. You can set it up any which way you want, but basically you just need to make it consistent. So let's go ahead and look at this left triangle, triangle ABC, we'll call it triangle ABC. ABC. You'll notice that this side over here on this left side of the hypotenuse is 3, so we'll call this the left. So 3 is our left. Okay, so remember that's our left, and we're going to put it over hypotenuse. It does not matter what order we put these in. You could have put this as 5/3. Doesn't matter as long as you are consistent with it. And what I mean by consistent is that you're going to have to set this equal to your second triangle. Let's call this triangle DEF. And as long as you're being consistent with your triangles, remember we put the left side on top. So it's the left side of this triangle. You'll notice that the left side of that triangle is just x, and the hypotenuse of that triangle is 30. Again, we have left over hypotenuse. And that's the goal. As long as you keep these the same, so you'll notice hypotenuse is on the bottom both times, left is on the top both times, then we can go ahead and handle this. And once you see this setup, if you ever see two fractions across an equal sign with a variable, you are going to be cross multiplying. So it's cross multiply and divide. 3 go diagonally, so 3 times 30 is 90, divided by 5 is going to give us our 18. So x is 18. Again, you could just type this into a calculator. 3 times 30 divided by 5 equals 18. And you can set up all of your problems like that. We would get the same exact answer if we put the hypotenuse on top. So even if we had done it like this, 5/3 is equal to 30 over x. 3 times 30 divided by 5 is still 18. It makes no difference regardless. Okay, and you can definitely test that with a calculator. You will get a couple of similarity problems that look exactly like this. So I hope you'll be ready for them. Okay, so that covers similarity. Hopefully you got that. Feel free to rewind if you did not. Let's go ahead and move on. From here, we also had our interior angle formula. Interior angle formula, and the related formulas, so to find exterior angle as well. So they're all going to be based off of this one times 180, and we're just going to add steps for each time we need more information. So what this gives you the sum of interior angles. So this is going to give you all the interior angles. There we go. So if I gave you a shape and I told you it was a regular polygon, so if I tell you that this is a regular, what kind of shape is this? Okay, it's not quite regular, but on the test, again, I will tell you that it's regular. I apologize, my shapes are never going to be perfect. But this is a 1, 2, 3, 4, 5, 6. It's a six-sided figure, so this is called a hexagon. Hexagon. Okay? So if you have a regular hexagon, and I ask you to find the sum of interior angles of interior dot dot dot. So interior angles, find the sum. What you're going to do is you're going to use this formula. N minus 2 times 180. So again, n is the number of sides. How many sides are on a hexagon? We just talked about that. That's 6. So it's 6 minus 2 times 180. And then we will just multiply this out. 6 minus 2 is 4. 4 times 180 is 720. And you could just grab a calculator for that. You definitely don't have to do that in your head. I'm not expecting you to be able to. You do, you are allowed to have a calculator on the test. So feel free. Anyway, that is how to find the sum of interior angles. So if I ask you to find the sum of all interior angles, that is exactly the type of math that you would use. Now let's go one step further. Now find the value of one interior angle. One interior angle. Interior. I've run out of room, so dot dot dot. So this says interior. I know it's really sloppy, but find the value of one interior angle. So if this gives you all of the interior angles of a hexagon, by the way, of a hexagon, what you have to do is you have to now take all of your interior angles, so all of them, and divide by however many sides you had. So how many sides are in a hexagon? Again, there are 6, so it's just 720 divided by 6. So what you'll find is that the value of one interior angle is 120. 120. Okay, and again, I just typed into a calculator 720 divided by 6, and you'll get 120. So the sum of interior angles is all of them. So n minus 2 times 180 gives you all of the interior angles. Divided by n gives you one interior angle. And let's go one more step. Now I need to find one exterior angle. Exterior means outside of a regular hexagon. Okay? So now I have to find one exterior angle. Let's go ahead and add one more step. So I know that one interior angle is 120. So basically on my shape, oh my gosh. Okay, that actually turned out worse than the first one, but still, I know that one interior angle is 120. So I need to find this exterior angle. To find that exterior angle, I have to remember that this adds up to 180 because it's a straight line. So because it's a straight line, I can just take 180, subtract what I know, the 120, and I will end up with what's left over as a 60. So that one exterior angle there has to be 60. Okay? So again, the main formula that you have to know for this is n minus 2 times 180. And then you have to understand that you have to add a step to find one interior angle and add one more step to find one exterior angle. Make sure you remember this. It will be on the test just like everything else. Okay? So that is the sum of interior angle formula. Similarity, interior angle formula. So after this one, what we covered in class is parallel and perpendicular lines. Parallel and perpendicular lines. Couple of special things that we have to know about them. You also have to be able to categorize lines. So make sure that you know how to plot your dots. So given two dots, all right, on a graph, always make your xy plane. Remember, x is the horizontal axis, y is the vertical axis. And as long as we know that, we can plot some dots. So let's say I had to plot 1, 1 and negative 2, 4. So 1, 1, 1, 1, and then negative 2, 4 is going to go left 2 because it's a negative. So 1, 2, and up 1, 2, 3, and let's say 4 is right there. So again, they'll meet up right here. I draw a line between my two dots, and I'll take a look at it. Remember that anything that we start reading a graph from the left and we go right. So you'll notice that if we trace this line, my marker has to go down. This means that this is a falling graph or a falling line. If on the other hand it had gone upwards, that would be a rising line. And then of course you have your other graphs where you can end up with this line here. This is called horizontal because it's going left to right. And then you have the one over here, and we'll have that line, and we'll call this one vertical. Vertical means up and down. So do remember the difference between your four. I will have you plotting dots on your test. Anyway, parallel lines are defined as follows. Let's go ahead and switch up colors. We've been writing in green for a while. So, parallel lines look like this. Parallel. You have two lines that will go forever and ever and never touch. That is what parallel lines do. They go forever and ever and never touch. You have to remember that their slopes, or their m's, so slope, are the same. They're exactly the same. So if the slope of this one is, well, these are horizontal, so I guess the slope of this one would be 0. That one would also be 0. They have the same slope. On the other hand, you can have something called perpendicular lines. Perpendicular lines, on the other hand, look like this. Perpendicular. They meet at a 90-degree angle. So they form this T shape. Upside down T, I suppose, in my example, but they form this shape. And their slopes are opposite reciprocals. That means that they have different signs, so one is going to be positive, one's going to be negative, and then they are going to be reciprocals, which means that in fraction form they will be flipped versions of each other. Okay? So opposite reciprocals. Let's go ahead and talk about how to solve for this. So if I give you an equation of a line, let's make any line. I don't know, y equals, where's my black marker? Y equals 4x minus 1. Given this line, and I want you to write the equation of a line that is parallel and goes through the point, I don't know, let's say 1, 1. 1, 1. Okay, so it has to go through the point 1, 1. What you have to remember for these is that you have to remember to be able to use this formula. Let's go ahead and do it in color. This is called y minus y1 equals m times x minus x1. So that formula is your point slope form, because it requires you to use a point and a slope. Luckily, because we know that we want a line that's parallel, we know that our slope is going to be the same as this one. So if our slope is the same as this one, you have to remember that this is our slope, so our m, or our slope, is going to be 4, and our points, so our y1 and x1, are right here. You know what, let's go ahead and make this 2, that way you can tell the difference. So remember, it always goes in order, alphabetical order, x comma y, so our x1 is 1 and our y1 is 2. Now that I know these three parts, I can just plug them into this equation up here. So y minus y1, so again y minus, and then we plug in y1. y1 we wrote up here is 2. You can put this in parentheses if you want, it doesn't really make a difference, but we'll go ahead and put it in parentheses because it was in the original equation, equals m, but we're going to replace m, and we wrote m right there, times x minus, and then x1. So our x1 we also wrote right here, and we said it was 1. Now I just have to solve and get y all alone. Remember, all of these have to be in y equals mx plus b form, so we just need y alone. So I'm going to go ahead and get rid of my parentheses, and to get y alone, I'm going to need to add the 2 over here. So let's go ahead and add the 2. So plus 2 on both sides, and you're just going to get y all alone is equal to 4 times x minus 1, and I'm really just rewriting everything. and then there's a plus 2 tacked on at the end. Okay, so now y is all alone, but this still doesn't look like what we're used to. It's still a little bit messy, it's still a little bit longer than we like, so we have to simplify it a little bit. Let's go ahead and distribute our 4 to what's in parentheses. So this is that distributive property that you learned back in Algebra 1. Y equals 4 times x is 4x, 4 times negative 1 is negative 4. So again, distributive property says multiply by that, then multiply by that. Alright, and then there's still that plus 2 hanging out at the end. This still doesn't look like y equals mx plus b, but we're really, really close. We just had to combine these two. After you combine those two, so negative 4 plus 2, hopefully you'll know that a negative 4 plus 2 is a negative 2. You get, you end up with y is equal to 4x minus 2. And you will notice, let's raise this a little bit. You'll notice that our new problem looks like this, and our old equation looked like that. These two lines are parallel because they both have a slope of 4. And they are different lines because they have minus 1 and minus 2. So you'll notice that they are really similar, but they are not quite the same. So let me see if I can't get this all on one screen real quickly. Alright, so 4x minus 1 and 4x minus 2. Okay, so that is how to deal with finding a parallel line to another line given a point. Let's go ahead and do the same thing but with perpendicular. So with perpendicular it's going to be a little bit different because their slopes are not the same. Remember that perpendicular lines have opposite reciprocal slopes. So let's go ahead and use the same exact example. So y equals 4x minus 1. So we're going to use that same line. Y equals 4x minus 1. And again, you're going to write the equation of a line that is now perpendicular. So we're going to write the equation of a line that's perpendicular and goes through. Let's use a different point this time. Last time we used 1, 2. Let's go ahead and make it go through, I don't know, 3, 1. It doesn't really matter what points we use. It just makes the problem a little messier sometimes, but it doesn't matter. I can use whatever point I feel like on this test, so get used to using any of them. So we're going to use 3, 1. And remember, that's x first, then y. It's the alphabet. X comes before y in the alphabet, so x comes before y on the coordinate plane. Alright, so perpendicular. Again, the first thing you remember on the last one is that I named my slope. I was like, well, my m is 4. Okay, so if I need to use the same equation, y minus y1 equals m times x minus x1. We're going to use that same thing, but we still have to name our m, our x, and our y. So our m is, and to find your opposite reciprocal, so it was 4, so your old m was 4, so then we have a little work to do. Old m, I'm going to call it m old, okay, mold. So our mold is 4. Please don't call it that, that'll confuse you. So yes, it's just our old m, so this was our old one, and it's just 4. And we have to change that. First off, let's make it opposite. Okay, so this is m new. It has to be the opposite, so it was a positive 4. The opposite of a positive 4 is a negative. Okay, so it's going to be a negative. So they're always going to have different signs. If this one's positive, that one's negative. If that one's negative, this one's positive. They just have to have different signs. And then it has to be a reciprocal. Remember that whole numbers can be written like fractions. A reciprocal is just flipping the bottom to the top and the top to the bottom. So it switches. Instead of the 1 being on the bottom, let's write it on top. And instead of the 4 being on top, let's go and write it on the bottom. This is the slope that you need for your problem. So we're going to go ahead and put it right here. Negative 1 over 4. And remember last time, we needed to name our slope, name our x1, name our y1. So here's our slope, so our x1 and our y1. And hopefully you'll remember that we got them from that point over there. x1 is x, so that 3, and y1 is y, so that 1. Alright, from here on out, let's go ahead and plug it back into our original equation right up here. So y minus, and what's our new y1? It's right there. Our new y1 is just 1, equals m, which we wrote right there, negative 1/4, and then we have x minus, and then x1. Remember, x1 was 3. So we're going to go ahead and put it right in here. Almost done, almost done. All we're going to do now is we're going to do the same thing as last time. Go ahead and add your 1 to both sides. So add 1, add 1. You'll get y all alone. And then you've got your negative 1/4 x minus 3 plus 1. And again, this is still not mx plus b. We're at the same spot as last time. You have to distribute this fraction. If you don't remember how to multiply, add, and subtract fractions, this will be a good reminder. Okay, so it's just y equals negative 1/4 times x. You're just going to write this fraction right next to x. So a number times a letter is always going to be that same number times a letter. And then negative 1/4 times negative 3. So remember, if we're multiplying fractions, negative 1/4 times 3. If you need to, you can rewrite the whole number as a fraction. Negative 1/4 times 3/1. And then you're just going to multiply the top by the top. So negative 1 times 3. And the bottom by the bottom. 4 times 1. And that's it. And you would be done there. Let's go ahead and plug that back into our equation over here. So minus 3/4. And then still plus 1. Now let's do a little separate lesson. Hopefully you remember how to add a fraction to a whole number. Maybe you do not, and that's okay. So we have a minus 3/4 plus 1. To simplify that, we need the same denominator. So remember, we can write whole numbers as fractions. This least common denominator of 4 and 1 is 4. So you'll multiply this by 4/4, because you have to ask 1 times what equals 4. Well, 1 times 4 would equal 4. So you've got negative 3/4. And then 1 times 4 is 4, and then 1 times 4 is 4, and then now we'll just add right across. Negative 3 plus 4 is just a 1, and then you keep your denominator. So negative 3/4 plus 1 is just 1/4. You also know that because 3/4 taken away from a whole. So if I had a whole cake or a whole pizza and it was split into 4, and then I took away 3/4, all you're left with is 1/4. So, I mean, there are a lot of different ways to do this, but anyway, your final equation here should be y equals negative 1/4 x. So we just rewrote all of this first part. Everything over here we just rewrote. But over here, negative 3/4 plus 1, we did the math for it, is 1/4. And again, you'll notice that it has the opposite reciprocal slope. Oops, sorry. So 4 and negative 1/4, they're opposite reciprocals and different intercepts. So this is the equation of a line, and this would be your final answer. And you'd be done there. Congratulations. Alright, so what we've covered are our interior angle formula problems, our similarity problems, and our parallel lines and perpendicular lines. One last topic. One final topic for my geometry students here. You guys learned your slope formula. And hopefully you'll have memorized this formula by now, but slope formula looks like this. Slope formula is just y2 minus y1 over x2 minus x1. And remember, this is just the same as saying rise over run. Okay? If you ever forget this slope formula, you always know as rise over run, so it's just how far up you go, so how far up and how far over you go. Rise over run. And remember, every change up and down vertical is on the y-axis, and then every change left and right is on that x-axis. That's why we do y2 minus y1, x2 minus x1. X's are on the bottom because you do rise first, so up and down first, and then left and right. Okay? So slope formula works like this, and I'm just going to give you 2 points. You can see it in 2 ways. I'm going to ask you this problem in 2 ways. I'm actually going to do the same problem, but I'm going to ask it in 2 different ways. The first way I'm going to ask it is like this. Here's point, I don't know, 1, 1, and I'm going to have you go to 2, 8, or 2, 4. Sorry, I was just deciding what would be easier. So 1, 1, and 2, 4. The reason I do this is because the second way that you're going to see this problem, it's actually the same exact problem. So we're going to do it the same exact way, but you're going to see this instead. I'm going to tell you that here's a point here, that's 1, 1, and then here's a point here, and this is 2 comma 4. So you could see it on a graph, but basically no matter what, you're getting the same 2 points. Sometimes I'll graph it and sometimes I won't. It really doesn't make a difference. It should not throw you off. I can give it to you in either format. So let's go ahead and apply our slope formula. Remember, the first thing you want to do is label your points. So this is x and y, x and y, x, y, x, y. Okay? And then your first point is just going to be x1, y1 because it's point number 1. Your second point is x2, y2 because it's point number 2. Again, 1, 1, 2, 2. And now I'm going to do both problems at the same time because they're going to have the same math. Okay? So remember, we're going to use our formula. So the first thing you're going to write is y2. y2, let's go and find y2. You labeled 4 as y2. Over here, 4 is y2. So just 4. Don't forget your minus sign. Okay, don't forget your minus sign. And then y1. y1 was just 1. Let's go ahead and make one of these negative just to make it a... Oh, well, I already graphed it like this. So never mind, we'll just keep it like this. So 4 minus 1. Don't forget your fraction bar. And then now x2. x2 is over here. It's a 2. And x1 is over here. It's a 1. Now let's just go ahead and simplify. 4 minus 1 is 3. And 2 minus 1 is 1, which we now can simplify to 3. This just means that your slope is 3. That's it. You would be done here with this problem. Slope formula is going to work the same way. Just label your x1, y1, x2, y2, and then plug them all in. Use a calculator if you have to, but just put in your numbers wherever they need to be. As long as you can put them in the right spots, you'll always get your right answer. Slope formula is the last thing that we covered for this test, so you've got everything that you need. Again, don't forget, the 4 topics that we covered were similarity, interior angle formula, parallel perpendicular lines, and then slope. So, similarity, that was at the beginning of the video. Feel free to go back to the beginning of the video where we described this. Interior angle formula, again, go back to the beginning of the video where we explained all of this. Okay. Parallel lines, perpendicular lines, and then slope formula. Okay, so those are the things you need to know for your geometry test. Make sure to study. You have your test on Tuesday. Best of luck. I will see you guys on Monday. Have a great weekend. Bye.